I'd like to invite Rob Randall to brief us on how Australia has approached STEM education. You'll see in your program notes that Rob was CEO of the Australian Curriculum Assessment and Reporting Authority from 2012 to 2019. He's lived and breathed the development of Australia's first national curriculum, and we're very honoured to have him here with us today. I just wanted to remind you that Rob's PowerPoint will be made available to you. And at this point, Rob, I know you're in the room, and I'm going to pass over to you. At the end of Rob's presentation, there's going to be a chance for some question and answers. So we're going to, when Rob finishes, we're just going to briefly return you to your rooms for a quick buzz about some things that you would like to follow up with Rob, and then there'll be the chance to put those questions to him. So thank you very much, Rob, and welcome. Now.
Thank you. Sorry about that. Can I just start by thanking everybody here? It's really great to hear the introduction and the aspirations and the goals that are there for you today. And while I'm not there, I could just see some of the rooms. I just want to acknowledge the efforts that people are making. What I've enjoyed in Australia is an opportunity to work with a great many people about trying to improve educational opportunities for young people in our country. And it's a deeply worthwhile activity. Even in the prayer, the importance of today's work and the acknowledgement of the difference it will make to our young people's lives and our country's lives. So can I just acknowledge that and commend you all for the effort that you're making. I hope that the contribution I can make this morning will help with that. So I today am going to go through a presentation, and as Kathy said, with questions and answers. I'm going to just deal with it in three parts. One that Kathy's already spoken about, the question and answers. But I just want to cover some background points, and then I'll get into a bit more of a discussion about why, how, who, what, from an Australian perspective. And then, as I say, we'll come to a close and give you an opportunity to reflect upon that and pose some questions. I always like starting things with definitions. I'm not going to dwell upon this because you have your own definitions, but I think it's really important from communication points of view and also to clarify why we are doing things. So here's some definitions I have drawn upon, and including one, the second statement down the bottom there. One's a publicly available one, but the second one is one from a national report that was prepared in Australia years ago, about 5 or 6 years ago, to develop a national strategy for STEM education. We've seen the importance of it, you see the importance of it, and that today is about trying to realise that. Second point of background is I want to just briefly talk about the Australian curriculum. As Kathy said, I had the opportunity from about 2009 to be involved in developing this. This cube is a sort of a simple diagram. It's always simple. These things are simple. That making things work in reality is much more complex, but it reinforces that when we designed our curriculum, we had three different perspectives or dimensions in mind. One is we made the commitment and reinforce the belief that subject or discipline knowledge has been important in the past, will continue to be important in the future. And one of the things we needed to do was to reflect upon what's the nature of that, the content of those subjects or disciplines. I'll revisit that as I go through some of the comments I'm making here today. What we added in the Australian curriculum, though, reflecting a lot of the work internationally about whether they're called 21st century skills or other things, we talked about general capabilities. We didn't actually think they were new things in the 21st century. We think some of these capabilities have been important for many years. The success that some of us may have had in education is because we developed those capabilities. The really important point, though, is we need to explicitly pay these things more attention and develop more young people's capability in them. Relevant to today are things like critical and creative thinking. Again, in the introductory comments, there's acknowledgement of the importance of that going forward. Personal and social capability, intercultural understanding and ethical understanding are 4 of the 7 capabilities that I will probably reflect upon as we go through today. And the last dimension, this one at the top, is what we call cross-curriculum priorities. in our attempt to write a new national curriculum, we thought there were three things that needed greater attention than they had in the past. One of them is sustainability. The other one's the history and culture of the first people of our country, and also then the geographical importance of Australia being in the Asian region, and that we wanted more young Australians to understand about Asia and Australia's relationship with Asia, not as just some holistic, one large region, but to understand all the histories and cultures of the countries in that region. So our curriculum was developed in that way in mind. I want to reinforce the point, though, that we design the curriculum setting expectations for young Australians wherever they are across our country. The diversity across our country and your country, the diversity is great both in many ways. And the important point, though, is the translation of curriculum intention into actual learning activities. And that's relevant to our discussion here on STEM today. And the comments that I have on the side of that slide reinforces the central role that we view teachers take in translating intention into reality, helped with guidance from departments and ministries and others. And again, I think that's important today. Part of your work today is to take an intention about STEM education and to work deeply in a focused way to be thinking about how you can translate, how you can help teachers translate that intention with guidance and support in others. The third bit of background that I want to just focus on is pedagogy. One of the things I have had the opportunity to be involved in over many years is some working with people who are doing research in the area of pedagogy or quality teaching. And within Australia, one of the models that's often referred to is one called the quality teaching model, developed by people at the University of Newcastle in New South Wales, and now being systematically validated in New South Wales, in Queensland, and in Victoria. I want to focus on this, though, because again, I think it's important that while we can have intention about what we want young people to learn, we also need to focus on how we think they will be learned, how we organise the learning opportunities for those young people. The model I'm referring to here has three dimensions. One's intellectual quality, one's quality learning environment, and one's significance. Now, we could unpack this model. It's always a good thing to do. I won't do that today, but what I want to highlight, I guess, is that in this model, they talked about the importance of intellectual quality, the importance of deep knowledge, deep understanding, higher order thinking. They're three of the things that we talk about when we talk about STEM education. In the quality learning environment, one of the elements of the quality learning environment is engagement. That's one of the very reasons that we think STEM education is important, because it's bringing something authentic and real and meaningful to young people's learning. It helps bring mathematics, science, engineering learning to life. And the other one was significance. The third dimension is significance. And a couple of the elements in that dimension is the idea of knowledge integration. The model says that young people develop deeper understanding of each discipline if they look at how it relates to others. And if they can integrate knowledge, the quality of their learning is improved. And also connectedness. The notion, again, of young people being able to connect what they're doing in the classroom, in school, with other parts of their lives, whether it's their personal life or their community life or others. So I'm highlighting here the combination of what we want young people to learn and how we want them to do it. Now, in my view, STEM is a convergence of those things, what we want them to learn and how we want them to learn it. While the title is a list of subject areas, it's much more than that. It's as much about not the what as the what, it's also important about the how. And combined, that what and the how, we can deliver the promise of STEM. So with those background in mind, let me move on now to the why, how, who, and what. I'm not going to dwell upon why STEM. This slide just says, here's some views that we had in Australia as a result of the National School STEM Strategy in 2015. You will have your own reasons. You could reflect upon and think whether your reasons for doing it are the same as those in Australia or not. I want to move into the how, and in a moment, the who. So the first point about the how is that we in ACARA, the organisation I was CEO of for that period of time, in 2015 undertook a STEM connections project in conjunction with the Australian Association of Maths Teachers. And this is a report. And so one of the things I'm doing here today is drawing upon that report. So instead of just talking about intention, talk about the work that ACARA did, working with teachers in schools, taking an intention and translating it into practice. This is just a reminder of what we did. I guess the next few dots, though, are also a key point, which is a feature of STEM, some of the projects that schools undertook. So these schools identified an issue, a need for a solution or a problem that they wanted to focus on, where they would draw together science, technology, engineering, and mathematics learning, both the content, but also the doing of those subjects. Sustainable biofuels, very popular these days. Safe water in rainwater tanks. The next one is design of a school sustainability centre, redesign of a school playground, redesign and adaptation of mousetrap dragsters. So again, some of them are fun things, some of them are deeper and more meaningful than others. The effect of exercise on health. Would have assumed young people would know that well, but we shouldn't assume those things. The design and construction of a vertical garden in school grounds. So there's a whole range. These are just some of the projects that were the focus of this work that ACARA did with these schools. And it's from the learning of teachers in these schools that some of the key things I'm now going to say arose. So the report that I talked about reinforced the notion of how we can improve the quality of STEM. So these are some, and again, what I've done is just take some key points. In the slides, the hyperlinks are available. So if you download the slides, you'll be able to get access to these reports. But as I go through this text from this report, as we often do with a pen or a highlighter, there are some things that stand out for me. The evidence from our project said STEM education, STEM knowledge, understanding and skills seem to be strengthened when their connections between the learning areas are emphasised. One of the things pedagogically is we shouldn't assume young people will make those connections. If we help them make those connections, then they can follow through. The idea of authentic learning, we know pedagogically continues to be important, where young people are maybe working on an answer to an identified problem or creation of a solution to something that's needed in their community or valued in their community. I think the important point here is when we start talking about science and technology in other areas, it's not just the knowledge, the science facts, the science knowledge, the science understanding. It's the inquiry skills which are at the centre of science. And in the Australian curriculum, we have a strand called Working Scientifically. It's the design process in technology, and that's a feature of the Australian curriculum in that place. And I also emphasise, and I mean, one of the points that was made in this report is sometimes people found mathematics one of the hardest ones to connect. But the observation was made about the value of just-in-time teaching. Here's an opportunity to actually teach young people and reinforce why they're doing some of that mathematics. The projects were designed to appeal to the interests of students. The study made the observation, if you take some things which were readily available, which were imported from outside, they were less effective than ones that the students and the teachers and the school themselves invented or came up with. Again, this hyperlink here goes to some of the work that ACARA's lists of projects and some work samples and illustrations of practice, and also a portal that's been developed within Australia called the STAR portal, which brings together a whole range of STEM initiatives, not all just freely available resources, but learning opportunities and activities for students and for teachers. Let me move on to this next point. The STEM report and the surveys involved gave us valuable insights about the different activities and different players involved in the work. The obvious point, maybe not always obvious, that schools, there needs to be a strong commitment from the school as a whole to this work. a whole school ethos that encourages working with staff, students and parents to get this shared understanding of STEM. Allowing for integrated approaches to assessment reporting, and I note later in today's program you're talking about that. Also, maybe allowing some time flexibility for staff to come together and maybe for students to learn. Maybe the timetable needs to change. Staff need to be committed to the underlying philosophy. I used to teach secondary maths, and sometimes maths teachers would be characterised by saying, no, we're just going to teach the maths. We're not interested in this other thing. What I do know, though, is exactly what I said earlier on, that if we are helping young people understand the application of mathematics, then their interest and engagement will increase. Another point the report talked about was sometimes the teacher needs to give over some autonomy and responsibility to the young people doing the learning, to relinquish their role as leader of learning, maybe a facilitator of learning. That teachers and staff, the collaboration skills, that requirements for collaboration maybe need to increase. And again, if I come back to assessment, if we're going to teach in this way where we're talking about integrated, more meaningful things, our assessment also needs to be richer and deeper. So we need to think about that. The other points here about communication, the community. We know that if we're changing something in school, engaging with the community, communicating with the community is important, also between teachers and others. The other point, just to briefly touch on, is the idea of partnerships. Many of these projects came to life when they were engaging someone outside the school, whether it's industry, whether it's just a local enterprise. Some of the schools that we worked with had farms, had access to community resources, and they contributed to the benefit of what was going on. A product of this project was a STEM Connections workbook. So not just researching, but trying to translate it. Then our intention of this project was to say, let's look at the value, let's look at what works well, and then let's give some advice to teachers about how. So there's some step-by-step guides here about maybe how you would go about planning it. Now, I want to reinforce, this is not saying, here's how the perfect way of doing it. This reflects a number of years ago, some views that teachers in our schools and the curriculum people in our authority thought was a good way to go. The key point in this, I just want to touch on this briefly and then start coming to a close. The key point in this was, though, the attention to planning. STEM just left to happen, or on the assumption, give them a problem, it will happen, I think it will fall over. A key point in this whole sequence here is the attention to detail and planning. It's not simply a matter of letting students go off and discover. Attention needs to be given to the opportunities provided by the idea, how the content of the curriculum connects with it, and as well, whether you need some explicit teaching to help young people make the most of this challenge or problem to deepen their learning. This is about deepening their understanding, deepening their learning, making the connections. They can only do that if they have some of the initial knowledge and understanding in the first place. So there's an important balance to be made between the teaching, which we might call traditional teaching, and then the opportunities for them to be able to apply their learning to an integrated problem and deepen their learning as a result. One of the other points I want to make is, in our project, we found that, again, it's not just something introducing a new idea and rolling it out. We found, and there were some comments made earlier in this, we found that the research highlighted that there are some groups in our population who we shouldn't assume or maybe less likely to engage in some of these areas. Now, it's an ongoing thing to watch, the engagement of girls, students from lower socioeconomic areas, in our case, Aboriginal and Torres Strait Islanders, and again, from different parts of the community, not necessarily just as one whole group, but we need to mind whether the likelihood of them to engage in this. And if there is some concern they won't, to investigate that and to build the scaffold and to put into place structures so that girls and students from these other groups get the most out of these STEM-related activities. The last point to reinforce is one I've made, the opportunity to engage with a broader community. Research is clear The more schools engage with the broader community, the better the relationships, the better the quality learning environment, and the more likely better outcomes that are come. And STEM is a great opportunity to do that. So what I've tried to do here today is to cover a bit of background quickly, talk a little bit about the why, how, who, and a little bit of the what as we went through it. I will, knowing we're keen to go through and get some questions, I'll stop there now, Kathy, and stop sharing and return to you. Thank you.
Thanks so much, Rob. There's so much in that presentation, and it's great that we've got the PowerPoint that people can use to get through to some of those reports and so on. What we're going to do now for about 3 minutes is each room is going to have a bit of a very quick buzz and brainstorm about any questions that you have for Rob about what he's said or the Australian approach to STEM. And I'm asking that the room leaders actually put those questions into the chat of the Zoom, and then Rob will respond to some of them with the time that we have remaining to be able to do that. So can people get around the table and just generate 1 or 2 questions that you'd like to ask Rob? We'll just give you 3 minutes to do that. Thank you. Okay, I'm just wondering now if each room could just put 1 question into the chat, and then we can get started. And we might get started as you're doing that, because I can see, Rob, that that there is some examples, some questions here, and the first question, Rob, from Dr. Clement is about the assessment of STEM education, and Pam Robinson is going to talk about a little bit about that later, but I wonder if you might like just to respond briefly to that question about the assessment of STEM education. And we are going to be looking at some examples of STEM in Australian schools in this program today. But there's also another question about how successful STEM has been in Australian schools. So I wonder if you might start responding to those questions, and other ones might come through in the chat, and I'll keep an eye on those.
Thanks, Kathy. The idea, how do we assess STEM education, and it relates to some other points there as well. I'd want to reinforce, as I tried to say, I think STEM education isn't something separate or in addition to maths and science and all those others. It's actually an approach to bring those together, to reinforce, to deepen the learning of the individual subject areas or disciplines, as well as the connection between them. The answer to Dr. Clement's question, I would start by saying, in that process I outlined, the first step in some of that process to say, what's the knowledge, the understanding we want young people to develop through this? What skills and capabilities? So as with all approaches to planning, if here's the learning we want to achieve as a result of this activity, that's the focus of the assessment. We don't do national, national assessment on it, but it's the assessment of these activities would be the same as others. What is it you wanted young people to learn? Design some assessment tasks which reflect that, and then use it in that way. I think how successful has it been in Australia? I think with many of these things, on the whole, great, but equally in some places there's room for improvement. We're pretty happy with the quality of the education system here, but we can always do better. And I think STEM is one of those ones. I think the challenge sometimes, whether it's success or not, it goes to some of those factors I highlighted and which are in the report. Whole school strategy, providing times for teachers to collaborate. If we're talking about STEM education, we're talking about a change in practice from how it might traditionally be done. So the success will be enhanced by creating opportunities for people to manage that change. I think one of the questions there, Kathy, is some samples. In some of the links I provided, and we could make this more obvious, there are some. They're on the ACARA website. There's illustrations of practice, samples of projects.
Rob, one of the questions is, I'll give you two questions and then you can respond to them together, perhaps. One question is, how was STEM education actually commenced in Australia? And what was a couple of key challenges in doing that? And the second question is about whether STEM is integrated into the curriculum or is just aligned to the curriculum. How is it reflected in curriculum?
STEM is STEM education, the STEM approach in Australia is a way of delivering the curriculum expectations. If I went back to that cube and I looked at the mathematics, the science, the technology we wanted to learn, in engineering in Australia in lower secondary is part of design and technology. In some of our states, engineering becomes a separate subject in senior secondary. So it is aligned. It is because it's about taking the learning expectations in those individual subjects, as well as our general capabilities, and creating a learning opportunity that enhances the opportunities for young people to learn them deeply in authentic ways. So it's absolutely aligned, but it's not, and absolutely it's not alongside or in addition to. Take the cube that I showed. STEM education is a strategy to deliver it. Interestingly, STEM in some places now becomes STEAM. The arts have been added to it. So it's an approach to bring learning together from across. We've always talked about interdisciplinary learning. STEM is an example of interdisciplinary learning. It's a more current example. Why did it come about? It's an attempt to give greater attention to those areas of learning. Technology, the importance of that in the future, increased numeracy, increased scientific literacy. In these days, those areas are much more important for many more young people to develop understanding of. So STEM was an opportunity to improve the learning in those areas.
Okay, what were some of the challenges, Rob, that we faced? Yeah.
So some of the challenges, again, I will repeat them because I think they're important. Some of the challenges were change. Again, if I just talked about myself as a maths teacher, I've probably been teaching, there'd be many people, maybe even younger than me, who've been teaching mathematics in a particular way and have got it all set and capable. So when we change, we expect teachers to change their practice. We should think deeply about how we help them change. Why are they making the change? What are some options for making that change? And how will they know if they're successful? Teachers, the world across, all want young people to learn. They're doing the best job they can and understand at the moment. So if we want them to change, why, how, and whether it'll be successful. So one of them was helping teachers to change. One of them is communication with parents. In the same way, we need to communicate why these things are more important than maybe they were in the past. So it's communicating, as I said in the slides there, with the parent community, with the broader community. And I think then the other way, which again helps address this problem, in Australia, we had our chief scientists involved. We had our bigger companies and technology companies involved, not just to help our teachers, but also to reinforce the value of it. So the challenges were, at a very simple level, change management, but it was, again, the why we're doing it and giving advice about how we're doing it, which I understand is part of what this workshop's about. Why, not so much the why, but how can we do it?
Thanks, Rob. There's a question here about from the physics and maths group, and it's about STEM curriculum standards. The question says, how is a STEM national curriculum being designed, and how can it monitor STEM curriculum standards? I wonder if you've got a comment about that.
Probably I'll reinforce, we don't have separate STEM standards as if it's something new. We're focusing on our science standards, and in the Australian curriculum, there's achievement standards for science, for mathematics, for technology. We focus on those. Probably the closest to a separate set of standards is some of those through illustrations of practice or work samples showing how those things come together. I think the difference, but noting the point of the question though, is the STEM, sorry, in the Australian curriculum, if I stick with science, because that was the key thing there, in Australia, we've talked about working scientifically. I actually think a key change will be not just the physics we want young people to learn, it's the working scientifically. So we'd be focusing on the element of working scientifically. How have we seen, what evidence we've seen of young people working in that manner, not just knowing about physics or chemistry or biology, but actually being able to use that. Same as in mathematics, working mathematically. How do they take that approach? That's a key shift. So I'd be looking, if you're looking for standards, I'll be looking in those skills or that process standards there, in addition to, or maybe more than, just the knowledge and understanding standards.
Thanks, Robin. Just one last question. You showed the model of the Australian curriculum, the cube. And of course, you noted there were learning areas, there were general capabilities, and there were cross-curriculum priorities. The question is, where does STEM fit into that cube?
STEM, if I took a slide, if I went into the cube, so the face where the learning areas, I could highlight maths, science, design and technology. So those three, because engineering is not a separate area. So if I'd take those slices through the cube, then I'd go to the general capabilities and I'd go looking for critical and creative thinking, personal and social capability, probably ethical understanding as well, and possibly as well intercultural understanding. So I'd take the slices that went through from the front face and I'd take the slices from the side, and then I look where that learning integrates. And in the Australian curriculum, we talk about those little intersections of those, and that's where I'd be finding the potential for STEM education. The new bit though, which is not in the Australian curriculum, is bringing the authentic tasks, the problems that we want young people to solve, the issues that young people are applying their knowledge. That's not written in the Australian curriculum. This process, from my point of view, then is working with young people in the local community and saying, what's a real issue, problem, or something in need of a solution that we can apply our learning to? The list I gave early on in the presentation was an example of some that young people in Australian schools came up with. So it's a combination of the curriculum meets a need or a problem that needs solving.
Look, thank you so much, Rob. That's been a fantastic introduction to our workshop today, and we've been very pleased that you were able to join our colleagues in Port Moresby and our colleagues in Australia. I know, because I know you well, I know that you'll be very happy if people want to follow up with you with some further questions and things like that. And thank you very much for the resources that you've brought to us today. So that was terrific, and I know that everyone will join me in thanking you for your presentation.
Thanks very much, Kathy, and thanks everybody, and good luck with the rest of the day. And I commend you again on the work you're doing. It's fantastic to see it happening. Thank you.
Thanks very much, Rob.